Hello, we're going to go ahead and review the Unit 1 assessment as part of Chemistry Mindset. This covers 1.1 through 1.3. There were 25 questions. A lot of it was 1.3. There was not a ton of 1.1 and 1.2. Next to nothing, in fact, because the majority of it was 1.3. So, let's go ahead. Which of the following is not a commonly used piece of lab equipment in chemistry? The correct answer is D, microscope. We don't tend, our microscopic world in chemistry usually can't be seen with a microscope. Beaker, graduated cylinder, and test tube was in that list of equipment in the 1.3 notes. Microscope is still used occasionally, especially when we're talking about biochemistry, but it is not used often. So number 2, what should be done if a chemical spills on the lab bench? The correct answer is C, notify the instructor and wait for further instructions. That's going to be the answer for a lot of these kind of questions. You should not be cleaning up chemical spills with paper towels. You should definitely not ignore it. And so that leaves C and D, and pouring water to dilute it won't always work. And that can just spread the chemical or chemicals across a farther area. So number 3, which of the following is a proper way to handle glassware in the laboratory? The correct answer is B, hold glassware close to the body when carrying it. You don't want to break it. And you don't want to place hot glassware directly on the lab bench. That can warp glass, in fact, if it's hot enough. You definitely should not handle broken glassware with bare hands. You can cut yourself. And don't dispose of broken glassware in a regular trash bin, because there could be chemicals on it, and you don't want that in the regular trash bin. Number 4, which of the following is not a safety precaution in the chemistry laboratory? The correct answer is B, wear open-toed shoes. You should never be wearing open-toed shoes in a chemistry lab. That should have been right away. And all the others are common safety precautions. I don't know if we necessarily discussed long hair, but that should be common sense. And you should also have recognized B was the right answer right away. So number 5, what is the purpose of a fume hood in the laboratory? The correct answer is C, to prevent the release of harmful fumes into the laboratory. So it's right in the name, fume hood. Oh, it has to do with fumes. You can get that right away. So number 6, which of the following is not a type of safety equipment found in the chemistry laboratory? This one should have been pretty easy. The answer is D. You're not going to find a coffee maker in any kind of lab, really. As long as it's separate from the actual lab area. Lab room, like in a hospital, you don't have a coffee maker in the like in the operating room. You have it in the break room. So number 7, what should be done with the unused chemicals at the end of an experiment? The correct answer is C, dispose of them according to the instructor's instructions. Of course, like I said, a lot of these kind of answers are going to be have to do with listening to the instructor or teacher, whatever kind of setting you're in. Don't pour them down the sink. Not all chemicals can go down the sink. Leaving them on the lab bench, definitely not. That's not even proper cleanup. And taking them home for personal use is extremely dangerous. You likely don't have as much experience with some of these chemicals as the instructor. So number 8, this is a common sense one and is likely review. Which of the following is a common laboratory solvent? The answer is A, water. Water is the universal solvent. That wasn't necessarily mentioned, but that should be common sense, probably review if you've taken some kind of physical science related course. So number 9, what does MSDS stand for in a laboratory setting? The answer is A, material safety and data sheets. We talked about this in 1.3. It was right there, I emphasized it. So all that is just right there is just knowing the notes. Unfortunately, that's how this first entire unit is. Very little applications, mostly just common sense and then just in the notes. So number 10, what is the purpose of labeling chemicals in the laboratory? The answer is C, to inform others of their identity and hazards. We talked about a risk assessment. You need to identify what the chemicals are and the potential danger they could cause. Now, of course, labeling chemicals does make the lab look organized. It does make them easier to find and probably does comply with lab regulations, but the main purpose is to inform others of what the chemical is and the danger they pose. So, number 11, what should be done before using glassware in the laboratory? The answer is B, inspect it for cracks or chips. We mentioned that we don't want to work with cracked or chipped glassware at all, ever. Rinsing it with water isn't the worst idea if you know that someone may have not washed it well enough, but that is only maybe once in a while. And again, you don't want unknown chemicals to go down the sink. So heating it in the oven, again, very rare scenario. If you're instructed to do so, you can heat it, but that's even heating it in the oven is not what you're meant to do. Usually use some other kind of heating method, usually not an oven. And wiping it with a dry cloth, I mean, again, glassware likely has some kind of chemical, even if it's just residue left over from maybe a previous group or previous use. You don't want to wipe glassware that may have some kind of chemical on it that you're aware of. Number 12, what is the correct way to measure a liquid in a graduated cylinder? We didn't talk about this, but yet again, this should be review. The correct answer is B, read the top of the meniscus. Meniscus is that little, it almost looked like a little smiley face, almost without the eyes. It's a little curve you read from. Now, I do want to emphasize measuring a liquid differs. So while this may be read top of the meniscus, it does also depend on the kind of meniscus. Like water, for example, is the bottom. Some chemicals are from the top. So this isn't the best question. I would actually go ahead and ignore this one. Obviously, this isn't a formal classroom setting. Like, this is just to see what you're doing. So I would go ahead and avoid this because it's not the best way to ask it. But we'll move on because reading the top of the meniscus does apply. So if you have mercury, for example, you read from the top because mercury curves like downwards. And sometimes you want to read the middle. So this one kind of differs. All of those are right except for D, depending on the kind of scenario. So I would say any of those answers except D are correct. 13, what is the purpose of wearing gloves in the laboratory? The answer is C, to protect hands from hazardous materials. Sure, gloves may keep your hands warm. That's not the goal of them, though. Preventing chemical spills, that's like... I mean, if gloves give you grip, they could prevent chemical spills, but their main purpose is to protect hands from hazardous materials. Number 14, the answer is C, recycling symbol. In that list of lab safety symbols in the 1.3 notes, recycling symbol was not one of those symbols. So flame was used for flammable materials, skull and crossbones was used for, I believe, toxic materials, and then the corrosive, symbol was used for corrosive materials. Recycling symbol is not one of those. So number 15, what does the term flammable mean in the context of laboratory safety? The answer is B, can catch fire easily. That's common sense. That is a pure common sense question. Number 16, what is the primary purpose of conducting a risk assessment before starting an experiment? We talked about this when talking about lab safety symbols. So the correct answer is A, to identify potential hazards and plan how to mitigate them. Now, cost has nothing to do with a risk assessment unless you're determining how much would we have to pay if we get injured. Calculating the time is not a risk assessment. That's just an overall kind of assessment. It's not a risk. Same with performing the experiment. It is hazards. So number 17, which of the following is not a potential hazard in the laboratory? Answer is D. Now, technically, too much light if you have a really sunny day coming through the windows, which not all labs have windows. The more professional labs likely don't have windows. If it's just a classroom lab, then you probably do. But all the three other ones are actual potential hazards. Again, this one's kind of common sense. Fire is obviously a big hazard anywhere. Slippery floors, if you're carrying like glass and you slip, you could break glass all over you. Sharp objects, same thing, broken glass, things like that. So too much light is not something you usually have to worry about. And if it's a really sunny day for some reason, then there are these things called blinds. And you could argue that, like, for example, burning magnesium creates a bunch of light. That is a hazard, but just look away from it. And that's a rare scenario. The other three scenarios can happen very often. So number 18, what should be done if a chemical gets into your eye in the laboratory? The correct answer is A, rinse with water for at least 15 minutes and seek medical attention. Common sense. I don't think we really discussed eye washing stations. But on any like bottle, if a chemical gets in your eye, rinse with water for X amount of time, seek medical attention if it's worse. Another kind of common sense question. You shouldn't rub it with a cloth, that can make it worse, especially if it's a like a grainier chemical. You could scratch the eye. That could cause issues. Ignoring it is a horrible idea. Cover the eye is also a horrible idea. That's the same thing with ignoring it. So number 19, which of the following is not a method of chemical disposal in the laboratory? The correct answer is D, throwing it in the regular trash. That is one scenario that will essentially never happen. So pouring down the sink with plenty of water can work with some chemicals, like, for example, chemicals used in maybe a laundry detergent that goes down the drain every day. Placing a designated waste container is what happens a lot of the time, especially if you're working with more solid chemicals. And following instructions for specific disposal methods, that also happens pretty often. So number 20, what does the term volatile mean in the context of laboratory chemicals? The correct answer is B, evaporates easily at room temperature. This was when we were discussing 1.3, I mentioned this. So toxic, radioactive, and unpredictable, like that's another case where you just have to know. This is not something you could deduce, because volatile, some people use it as unpredictable, but it's really, in a chemistry setting, it's evaporating easily at room temperature. Means it lets off a lot of fumes. So number 21, what is the purpose of an eye wash station in the laboratory? Correct answer is C, to rinse chemicals off the skin and eyes, mainly eyes. That is yet again another common sense question. It's an eye wash station, you wash the eyes. You don't use it to refill water bottles, that's not its purpose. You don't use it to wash hands or glassware. Those are what sinks are for, or designated glassware, I don't know, washing stations. But number 22, which of the following is not a piece of personal protective equipment, or PPE, commonly worn in the laboratory? This is one of the first things we discussed in 1.3. So the correct answer is C, helmet. Unless you're working with a giant rock, I doubt you'll need a helmet. A lab coat to protect chemicals from getting on your actual clothing or your skin. B, safety goggles. Always need those safety goggles or glasses. That's safety glasses. Your normal glasses that you wear every day aren't gonna work. And gloves. You should wear gloves if you're working with any kind of dangerous chemical that could burn or irritate the skin. So number 23, what does it mean to waft a chemical in the laboratory? The correct answer is D, to gently wave air toward the nose to detect odor. I mentioned this when we were discussing I should never smell or taste the chemical. And wafting is the way to detect an odor. You just don't want to stick your nose in chemical. Number 24, what should be done if a fire breaks out in the laboratory? The correct answer is A, use a fire extinguisher if trained to do so, or evacuate the area and call for help. And again, a fire extinguisher should only be used if the fire is small enough. If it's engulfed half the room, it's probably best to evacuate if you hadn't already. Fire will almost never go out on its own. Pouring water on it is a bad idea because, like, for example, if you know a grease fire is, pouring water on it makes a grease fire worse. An attempt to putting out with bare hands, that is just not a smart idea. You shouldn't just grab the object that is on fire. You will lose functionality of your hands. Number 25, what should be done with broken glassware in the laboratory? The correct answer is C, dispose of it in a designated glass waste container. Don't throw it in the regular trash. Could have chemicals on it. Don't leave someone else to clean it up. That is just incredibly rude. And throwing it in the sink and running water over it doesn't always work. Designated glass waste container will always work. It's all 25 questions. If you have any extra questions, you can always send an email. Have a good one.